In this lesson, we learn how to find the nth term of a given arithmetic sequence. Arithmetic sequence, also known as linear sequence. For such a sequence, there is usually a difference between a term and the next term preceding it is, and such difference is always a constant. And the difference, we call it the common difference, which is usually denoted by letter D. A good example of a linear sequence is here, which is 7, 11, 15, 19, and so on and so forth. This dot here implies that the sequence continues indefinitely. And if you look at this sequence, we notice that the next term to the first term is obtained by adding a 4, and the next term to it is again obtained by adding a 4, which gives us 15 in this case. We add a 4 again to get 19, and so on and so forth. So any sequence whereby there is a constant difference between a term and the next term to it is called a linear sequence or arithmetic progression. The goal of this lesson is to learn how we can take this information as the constant difference and turn it into a particular formula that we can use to determine any term in a given sequence. And there are two ways to approach this. There is what I call the long method and the short method. So I'm going to introduce us to both of them here. Let me start with the short method. Because for this sequence, I have 7 as my first term, and the next term to it is 11, which is obtained by adding a 4. So our common difference here is 4. D is 4. So since D is 4, we can say that the first term is 7 plus 4 times 0. 4 times 0 is of course 0, and 0 plus 7 is 7. This is T1, not T2. T1. Then T2 is 7 plus 4 times 1. 4 times 1 is 4. 4 plus 7 is 11, which agree with the term there. T3 is 7 plus 4 times 2. 4 times 2 is 8. 8 plus 7 is 15. Again, it agree with the term there. T4 is 7 plus 4 times 3. 4 times 3 is 15. 15 plus 7 is 19 rather. 19. Again, it agrees with the term there. Now, if we compare this number here and this number here, the difference between them is 1. 1 minus 1 is 0. Again, if we compare these and these, the difference is again 1. 2 minus 1 is 1. Compare this and this, the difference is 1. 3 minus 1 is 2. This and this, the difference is again 1. 4 minus 1 is 3. That means Tn will be 7 plus 4 times n minus 1. Why n minus 1? Since this is decreasing by 1, these two will decrease by 1, these two decrease by 1. That means n2 should decrease by 1, which is n minus 1. That is 7 plus 4n minus 4. That is when I open up this bracket. Okay, let me rearrange this a little. That is 7 minus 4 plus 4n, which is 7 minus 4 is 3 plus then 4n. That means the nth term of this sequence Tn is 3 plus 4n, which I can write as 4n plus 3. Okay, that is a short way of getting the nth term of a sequence. Now let me go and do the long way. For the long way, let me prepare a table for the terms and their position. Their position, I will denote that as n. Then the term will be the term of the sequence. Let me first of all write each of the term there: 7, 11, 15, 19. 7 is in position 1, 11 in position 2, 15 in position 3, 19 in position 4. Okay, now let's get their differences. The difference between 7 and 11 is 4. The difference between 11 and 15 is again 4. The difference between 15 and 19 is again 4. So it's a linear sequence. Now, for a linear sequence, any linear sequence for that matter, the general term is denoted by Tn is equal to An plus B. Now, our goal here is to find the value of A and the value of B. And to do that, let's prepare another table. Just like the first table we have here, let me call it table 1. Table 1. For the table 2, remember this table 1 will show the term of the sequence and their position. The position of 7 is in n1, that is when n is 1. When n is 2, the position 11. When n is 3, 15. When n is 4, 19, and so on and so forth. So if the general term of the sequence is An plus B, what if I put n into that? That is A times 1. That is, if I say n equal to 1, A times 1 plus B. A times 1 is of course A. N plus B will be my first term of the sequence. So let me prepare another table n and then the term of the sequence. When n is 1, the term of the sequence is A plus B. What if n is equal to 2? That is, if n is equal to 2, I put 2 into this. A times 2 is 2A, then plus this B. So when n is 2, the term of the sequence will be 2A plus B. What about if n is equal to 3? A times 3 is 3A, then plus this B. So the term of the sequence will be 3A plus B. And then when n is 4, the term of the sequence will be, again, put 4 here. A times 4 is 4A, then plus this B. Now 4A plus B. Okay, just like we did in the first table, we subtracted the term from each other to get this common difference here. Let's do the same thing here. When we subtract this from this, 2A plus B minus A plus B, B minus B is gone, so 2A minus A is A. And then again, I subtract this from this, B minus B is gone, 3A minus 2A is A. Subtract this from this, B minus B again gone, 4A minus 3A is A. Okay, let's call this one table 2. I want to compare something. Now, if you look at table 1, the last row in table 1, which is 444, corresponds to the last row in table 2, which is what? AAA. Therefore, if we compare the element of table 1 to table 2, we can say A is equal to 4. Again, if we compare the first row in each of the table, the first row in table 1 to the first row in table 2, comparing the element, we have A plus B correspond to 7, 2A plus B correspond to 11, 3A plus B correspond to 15, 4A plus B correspond to 19. With that information, we can find the value of B. If that is the case, Because that you can choose any of these, either a plus b equal to 7, or 2a plus b equal to 11, or 3a plus b equal to 15, or 4a plus b equal to 19. Any one you equate, you are going to arrive at the same answer. Let's check it out. Let me start it with a plus b equal to 7. Equal to 7, equal to 7, and I wrote 17. Sorry, that was a blunder from my side. So a plus b equal to 7, and we've known a to be 4. That means 4 plus b is equal to 7. B therefore is 7 minus 4, which is 3. Okay, that is when comparing the first term in this second table with the first term in the first table. Let's compare the last term in each of the tables and see whether we get the same thing. So for that, we have 4a plus b equal to 19. 4a plus b equal to 19. Now what is a? A is 4. That is 4 times 4 plus b equal to 19. 4 times 4 is 16 plus b equal to 19. B therefore is 19 minus 16, which is 3. So you can see we get both the first one, comparing the first term and this, we got the same thing, 3. So we know the value of a and b, and we say that the general term of a linear sequence is Tn equal to an plus b. So putting in the value there, Tn is an plus b. A is 4, that is 4n. B is 3 plus 3. So Tn is equal to that. You can see we get the same thing. When we use the short method and the long method, we arrive at the same answer. So that is what I got for you in this video. In the next one, we will learn how to apply this knowledge to find the nth term of a given sequence.